So good afternoon, everyone. Again, thank you for joining us. Thank you for joining the Prospect Heights Public Libraries program. I'm Terry Campbell, your host today. I want to welcome Alice Bell, co-director of the UK climate change charity Possible. She has a PhD in science communication from Imperial College, London. Her book, Our Biggest Experiment, An Epic History of the Climate Crisis. We want to welcome you all the way from London. Welcome, Alice.
Hello, welcome from London where it's 7 o'clock. So welcome from the future. So far, we haven't had a comet hit or anything like that. It's all good in the future. It is dark where I am, but I hope it's light enough that you can see me. And I've got some slides so you don't have to look at my face. They are, as I should warn you though, I'm mainly going to be talking about the history of some scientists. So they're mainly just pictures of old dead men. But I hope it at least gives you something else to talk about, and I've tried to vary them a bit. I'm going to be talking about my book, Our Biggest Experiment. Actually, I realized before I was preparing these slides earlier, I've got the British cover, which is exactly the same as the American cover, except that the American edition has the word epic in the title. It's an epic history of the climate crisis. The content is exactly the same. It's just typical Brits didn't want to say it was epic because we like to be a bit more understated. Obviously, the book is epic, and it is an epic story. I wrote it because I'd been studying and working in climate change for years. I've worked in the intersection of science and policy for about 2 decades now. It makes me feel old when I think about that. And I've been specializing in climate change for the last 10, but I mean, I'm young enough to have lived with the kind of concern about climate change my whole life. You can be quite old now and to have lived your entire life with an awareness of climate change and a concern about climate change. And as I was working more and more on the issue, I started to study it more and more, and I learned a lot about the science. I came across a lot of numbers. I heard a lot about various great men of history who'd done something or other, but I didn't really get a sense of that backstory of how we had got into this mess. I kind of knew, I could look at a graph and people would say coal is a problem and oil is a problem. People would say, oh, it's the climate skeptics who are a problem. But I couldn't really fit that into a story and get a real sense of the rich background as to how we had built this problem. And also I hadn't really got a sense of how we discovered it. I kind of was told that climate change was happening, and I was given really good evidence, and I could see that evidence challenged by various people and examine the background to that. And to an extent that, I thought I believed it and I understood it, but I still didn't know. When was it that we started to know about this? Because, it's not obvious to the naked eye. You can't look out the window one day and go, oh, climate change. You might think over a period of years that the weather is changing. I'm sure a lot of you have felt that and have thought, oh, the weather is different, or we're noticing maybe flowers bloom or things like that at different times of the year. We might notice that, but we wouldn't necessarily know it's climate change. It's not obvious. It takes a lot of science and understanding, and actually centuries of interdisciplinary researchers working, connecting their ideas from all around the world before we have the knowledge that it is this thing that we call the climate crisis. And I wanted to get a sense of, when did that happen? Every now and again I'd tumble over something somebody would say, oh, we knew about this in 1864 or 1927, and I go, well, what does these dates mean? How did we know about it that long and not do something about it? I wanted to understand that, and so I started tracing back to try and learn a bit about the history of how we got into this mess and also how we discovered it. And I learned that these stories really intermingled together. They connected together a lot, and also they just had this incredible cast of characters, these amazing people. I mean, like, just even I'm not going to talk today too much about the energy industry or the oil industry, but one of my favorite bits about reading up about this was reading up about the people who built Shell. Like the Shell, I actually live not too far from Shell HQ in London. I walk past their HQ quite often and sometimes see protesters outside that, and you think of it as this big evil oil company and you're sort of told to think particular things about it, but it has its history. It's called Shell because they used to sell shells not far from where that HQ is now, actually just in the East End of London. It was just some traders. It was a family who were making a living selling various different things that sort of fell off the back of a boat on the East End of London, and gradually they built this up to have trading links across Southeast Asia, and then they were really good at trading and moving things around the world. So some oil companies asked them to move some oil around, and then they became really expert in that. And 150 years later, they are this behemoth of an oil company that seems so almost impossible to imagine it not existing, or certainly very challenging to imagine it selling anything other than oil and gas. And yet it started off selling shells. You know, this is an incredible story of the people behind that, the Marcus brothers who built the Shell, and how they had to battle things like anti-Semitism and class prejudice because they were working class. There were lots of very snobbish people in Victorian London who looked down their noses at them. And there's just, you know, that I should think of them as the baddies. They invented Shell, but actually they're kind of sympathetic characters too, and they're really fascinating. And all these scientists, some of them, you might think of them as great heroes at first, but also discover that some of them were really awful people. They did some good for the world, they found us some knowledge, but sometimes they were really not great. Or they were just, you know, it wasn't that they were good or bad, they were just normal human beings, and they had interesting, weird lives. And I loved collecting all these stories, and so I put them together in a book, which I hoped other people would also be interested in it. And I hope that I also found that, having studied it, researched the book, I felt that my understanding of the climate crisis was so much richer, was so much, I felt I understood it much more. You know, I thought I understood the climate crisis when I looked at the graphs and talked to the scientists, but actually I feel like I only really understood it when I had a deeper understanding of the history as well. And so I hope that if any of you have read this book or you're thinking of reading it, it will leave you with it'll give you some interesting stories about some interesting and weird people, and it should be, I hope, an enjoyable read, but it also will leave you with, I hope, a slightly more enriched understanding of the climate crisis, about how we got into this mess and how we discovered it. And what I'm going to do today is just take you through some stories of the people who helped us discover the climate crisis. So how we got from looking out the window thinking weather's a bit weird, to our modern understanding of being able to track and understand weather changes, and get an explanation as to why that might be something that, you know, this thing that we call carbon dioxide. So when people talk about the climate crisis, this is kind of my starting point for a lot of working on this book. When people like me, I'm a professional climate campaigner in my day-to-day job. When we talk about the climate crisis, we often throw a lot of numbers at you. So we'll say 1 degree warming, or 1.2, or 3, or if we really want to scare you, 4 or 5. We might talk about how much carbon dioxide is in the atmosphere and say something like 415 ppm, as if you're expected to know what that means. We might talk about the number of climate talks we had. So we just had big climate talks in Glasgow in the UK in November. They were COP26, and people are meant to know, like, COP26, what about 25 and 24? And what are all these different numbers that are thrown at us? And sometimes these numbers come alone, 26 or 1.5. Sometimes they come with friends to compare them to things, to say, oh, it's 30 degrees today and 32 tomorrow, or something like that. Sometimes they come with a load of friends all plotted together on a graph. And here is one of my favorite climate graphs. There we go. It is called, can you all see it? Just check, let me know if you can't. This is a graph known as the Keeling Curve. It's called Keeling after the scientist, Dr. Keeling, who set up the research. And it's a curve because it's going up. And it's got this characteristic zigzag to it. And what it is it is a record of some data that is collected in an observatory in Hawaii on how much carbon dioxide is in the atmosphere. And if you look at the bottom left-hand corner, it starts a little before 1960. And this is the most recent reading that they have on the website. I took it from their website today. It's from a couple of days ago, 10th of January. And you can see that carbon dioxide levels started at number 310. And they're now they're sort of approaching 420. And this is, they measure how much carbon dioxide is in the atmosphere, how many bits of carbon dioxide there are for every million bits of atmosphere, which is the ppm, parts per million. So for every million bits of atmosphere, how many parts of that are made up as carbon dioxide? And in 1958, you can see it was around 310, 315. And in 2022, it's sort of around 410, 415. And that might not seem like very much. Parts per million, just the difference between 300 and 400 parts per million might not seem very much, but we now know that that seemingly small difference can actually really mess with the chemistry of the atmosphere and create quite a lot of warming. And that difference is the difference of several degrees Fahrenheit warming over the time of that period as well. And one of the things that's really people know about this graph is, well, it's going up. Levels of concentrations of carbon dioxide is going up, but it's also got this zigzag line. And when they started doing this research in the 1950s, well, by the early 1960s, when they had a few years of data, they could start to see this zigzag happening. And they were like, oh, that's really interesting. So it's going up and it's going down, up and down. And they realized it did it with the seasons. And what this was the greenery in the northern hemisphere, where there was more trees on land, was in the summer growing, and in the spring the leaves were bursting out, and then in the autumn and the fall they were falling back and they were dying out. And what these zigzags are, it's incredibly beautiful. What the zigzags in this seemingly quite boring graph, it's the earth breathing, basically. It's earth breathing in and out. And I love this graph so much. I actually have a reading from it tattooed on my left shoulder, along with some of my friends. It was something we did on the run up to the Paris climate talks in 2015. And when I first started studying this graph, and I learned about the rising carbon dioxide levels, and somebody told me this thing about the earth breathing, and I thought that was really wonderful. And a friend pointed out that you could find the year that you were born on the graph and think about how much carbon dioxide there was in the atmosphere in that year. Which is actually the bit that I have tattooed on my left shoulder. It's the reading. So very clever people it can work out how old I am. My reading is 340. So the levels of carbon dioxide when I was born were 340 ppm, which situates me somewhere on that graph. I'm old enough that I'm not going to tell you how old I am. But you could see where you were, and you could go into their data set and look up what were the ppm readings on the day that JFK was inaugurated. The day that Nixon was inaugurated, the day that Trump was inaugurated, and the differences between them. But I was looking at it, I was like, okay, well, why is it called Keeling? Who was this Keeling guy? And also, because I used to work in science policy, trying to get funding for looking at science funding and things. It starts in 1958 and it goes on to today. That is incredible that is a piece of research that managed to be started in the late 50s and is still running today. That is just amazing. It is one of the very few bits of research that would last that long. And I wanted to know what happened in 1958 that made someone start to measure carbon dioxide. What was so important about 1958 that made somebody go, I'm going to stick a bit of equipment in an observatory in Hawaii and start a project just to track how much carbon dioxide is in the atmosphere? And that's sort of the starting point of me unraveling the story and trying to wonder what's going on in this story. It's like, okay, well, there's a lot of things you need to know before you'd even start to build this graph. First of all, you need to know that carbon dioxide is a thing. Because actually, it's not obvious that carbon dioxide is a thing. Like, we learn when we're kids at school that we breathe in oxygen and we breathe out carbon dioxide. And then we learn that plants do it the other way around, and that animals are the same as us. And we maybe get a sense of like air being good or bad. If we're worried about the environment, we might worry about pollutants in the air. We might feel them, we might start choking. We had, where I live in central London on Friday, they told us that we shouldn't exercise outdoors because the air pollution was so high. I knew that because I live in a city and that we get warnings about this. And I live in a not very polluted city compared to many around the world, but I live in a polluted enough city that we have warnings like that. So, but I can't see it with my own eyes. I need to be told that by people. I needed to be told as a child that I breathed in oxygen and breathed out carbon dioxide. Didn't know that. And it's only really a few hundred years ago that we managed to have this kind of knowledge. So we have, this man is a guy called Joseph Black. He was a medic and scientist in Scotland in the end of the 18th century, which is why he has hair like that. It looks like he has an excellent coat. I've just realized how really quite wonderful his buttons are. I'm quite jealous of his buttons. But he would like to hang out with people like James Watt, who helped develop the steam engine and in many ways is the cause of climate change. People like Adam Smith, the famous economist, and all sorts of other learned men in the Scottish universities. Around the sort of mid to late 18th century. And he started off as a medic because if you were interested in science, you probably learnt to be a physician, but that would allow you to do chemistry. It was before chemistry was a subject that people studied separately at university. In fact, Joseph Black would go on to be one of the very first chemistry professors in the world, because he would start off just playing with different chemicals as a way of learning about medicine and thinking about treatments for health, but would get really interested in the chemicals and started to help build this discipline that we now know of as chemistry and have to study at school and maybe get very annoyed with our teachers making us draw lots of hydrocarbons out. And so Joseph Black started off when he was a medical student at Edinburgh, and he was just studying, as part of his research project to finish his degree, he was studying how to dissolve kidney stones. So some of you may have suffered with kidney stones, probably aware of what they are. It's quite hard, and thinking about treatments that might break down these kidney stones. So he had forms of sort of calcium carbonate that he wanted to dissolve. Now, we would now understand what he was doing was playing with acids and alkalis, the sort of basic stuff that we would do in chemistry class at school. But back then, they were just still figuring that out. They didn't have ideas of acids and alkalis. They hadn't a sense of that these ideas of, nobody had really even invented chemistry, let alone languages like that. And they certainly didn't have an idea of air as being made up of this soup of chemicals that we would now understand it of. It was just air. It might be bad air, it might be smelly, it might be unhealthy, but it was just air. And what he managed to do while he was playing around with these, he was just kind of trying to dissolve really kidney stones, was he found that this gas was given off when he was playing with some of the different chemicals, and that if you put a lit candle near this gas, it would go out. And he identified what he called fixed air, and would gradually now be known as carbon dioxide. And it was work by him and other scientists of his time which helped expand this idea of just air, which, for people when he was a kid was just air around you, and for lots of people even after he died, it's just air. Suddenly became this incredible complex mix of so many different chemicals, and people were pulling out what we now actually would call greenhouse gases like carbon dioxide and nitrous oxide and lots of other things that we have chemical names for, sort of pulling them out the air and doing all sorts of exciting things with. In fact, there was a guy called Humphrey Davy, who, if any of you have heard of Michael Faraday, was a real leader in electricity research. Humphrey Davy is probably most famous as Michael Faraday's mentor. So this is the beginning of the 19th century. In sort of London, you might see in kind of Jane Austen books or something like that. And Humphrey Davy would present a lot in sort of luxurious London lecture theatres and show off science to the people. And he loved nitrous oxide, and he was the man who first discovered that you could isolate nitrous oxide, and if you breathed it in, it would make you happy. And he used to take a bladder of nitrous oxide, which is kind of like a balloon these days, I suppose, and take nitrous oxide and have nitrous oxide parties, which is sort of thing that people in London in the early 19th century would do. But I often think about that when I see people complaining about young people today, and I think, well, this guy was celebrated by the richest and poshest people of London in his day. And now we worry about nitrous oxide being in the atmosphere and creating global heating, but we only know it existed because this guy literally pulled it out of thin air and started getting high on it in the early 19th century. Anyway, to move on to some other important areas of science that we needed to know about before we have this weird Keeling graph, we also needed to know that carbon dioxide could create warming in some way, that it might do something for the atmosphere that would be worth us studying. It wasn't just, most of the early studies of carbon dioxide were to do with oxygen and respiration and breathing. The first people who were studying these things were thinking about health. In fact, this guy, Humphrey Davy, discovered nitrous oxide because he realized that people could breathe in oxygen and it was a life-giving force. And he thought maybe these other gases that he could pull out from the air might heal people. He initially tried it as a medical cure. It's now used as an anesthetic. And they had no idea that it would be used as an anesthetic, but they thought it might treat people who had TB or something. And so some of the first studies were looking at that. But by the middle of the 19th century, there was a sense that maybe carbon dioxide could have a warming effect on the Earth. And the first person to really tell us that was an American scientist called Eunice Foote. And now this slide is blank because we don't have a picture of Eunice Foote. What we know about her was that she was a woman, a middle-class woman, able to enjoy studying and learning science and not having too many kind of worries about having to make money and survive, living in New York State in the middle of the 19th century. And her husband was a lawyer and also a scientist and an inventor. And they both really loved doing science. And back then, you didn't have to be a university professor to do science. You didn't need to have a white coat or lots of degrees. It was a bit more normal that you might be just an enthusiastic middle-class person who has some spare time and would study some science. And so her and her husband both did quite a lot of experiments at home. And she did an amazing experiment in 1856, which we now look back and think of as incredibly visionary. But for her at the time, she thought she was just playing around with some of these gases. You know, this thing that Joseph Black had discovered, several decades before, this thing called carbon dioxide. They're just playing around with it, learning about it. People have been pulling these gases out of the air. They've been trying to treat health problems with them. They've been getting high on them. They've been thinking about new weapons they might do with them. They've been learning about the respiratory system. And she was like, well, we can just study them. We're interested. And she was also interested in the nature of heat. This, along with gases, was something that chemists, as the rise of chemistry got bigger and more interesting to people were interested. Well, what is heat? Like, you set fire to something or you boil water. What does it mean to boil water? How is heat moving around? These things that we learn about at school and now seem really intuitive to us, that heat is an energy and it transfers and stuff, had to be discovered and was being unraveled. And so as a woman who was interested in science in the 1850s, Eunice Foote thought, I'm going to think about heat and I'm going to think about gases. And she set up quite a simple experiment on her windowsill. She took some tubes and she filled them with different gases. She filled one with a sort of damp air, and she filled one with a dry air, and she filled one with just plain air, so she had a control, and then she filled one with carbon dioxide, and she put them on her windowsill on a really, really sunny day, so the sun's rays would hit these different tubes of gas and saw what happened. And being a good scientist, she recorded it. She took temperatures for them and she recorded the temperatures. And she found that the cylinder that was filled with carbon dioxide held a lot more heat than any of the others. So if you compared it to one that was just a normal mix of air, a normal mix of gases of just standard air, it got very hot, and it stayed hot for a very long time. And she wrote up her results in a paper, and she presented it at the American Association for the Advancement of Sciences annual conference, which was held not far from where she lived in New York in 1856, which was one of the biggest and most important scientific conferences at the time. And in her paper, almost in passing at the end, she says, if you had an atmosphere that had a lot more of this gas, so instead of there just being a little bit of this gas that she'd had to pull out of the air to fill her cylinder, if it was mainly this gas, it would get very hot indeed. And that, now looking back, you think, now we spend so much of our time arguing over how much carbon dioxide is in the atmosphere, worrying about how much more carbon dioxide might be put into the atmosphere and how much hotter it might get. And this woman in 1856 was the first person to go, if you put a lot of carbon dioxide in the atmosphere, it's going to get hot. And that was when humanity first really had some kind of warning about this thing we would now call the climate crisis. But no one paid much attention. And that is one of the reasons why this slide is blank. We don't have any, she wasn't this great visionary scientist that everyone listened to and remembered and wrote down their name and painted paintings of and took photographs of and kept in the record books. She was largely forgotten. It was only about 10-15 years ago that it was actually a retired oil scientist, a geologist. I was just interested in this issue and was looking back on the records of some old journals and found this paper and went, look, there's this thing that this woman said that, now seems really visionary. And now I think she's really celebrated and talked about more and more. People quite often come to me and tell me about her in a way that even a few years ago, I would tell stories like this and people were like, what? There was a woman in 1856 who said this? But at the time, no one really knew. Now we think that she was rich enough and where she lived in the world at the time she lived, there probably is a photograph of her somewhere. She would have been photographed at some point in her life, and it's probably in somebody's collection. She also was a women's rights activist. She kind of got around. Her daughter married someone quite semi-famous, I can't remember who it is, it was a politician of some sort, so there's like a record of her in some news reporting because of that, as well as records of her some of her activism, as well as the journal articles that she left behind. But no one knows where this photograph might be because it's not been catalogued with a label going the great Eunice Foote. So there is an amazing hunt on to find this photograph, because we think it's probably just buried in some archive somewhere. It's sitting in some library in someone's box somewhere. And it may well have been digitized. It might be on the internet, and we just don't know because there's just so many pictures of women in the 1870s in New York State on the internet that we don't know it's her. So there's a project actually trying to use machine learning to find it. And I really hope that in a couple of years, if I'm giving talks like this, I'll be able to show people a picture of Eunice Foote. But she was largely forgotten and ignored at the time. Luckily for science, though, a man came along and said exactly the same thing a couple of years later. And we do have pictures of him. We have lots of pictures of him and his amazing beard. This is a man called John Tyndall. And he worked in the same institution in Mayfair that the man who had discovered nitric oxide could get you high worked in, but a few decades later he worked at the Royal Institution. And he had been born, he was Irish, although he would have very much thought of himself as British. He was politically, he wouldn't have liked us necessarily to distinguish between the two. Oh, sorry, getting ahead of myself a bit there. Yeah, John Tyndall, he lived in London, and he had, now you can look at this story as Eunice Foote said this thing in 1856, and then this man said exactly the same thing like 2 years later, and he gets all the credit. And I am kind of here for that argument, but at the same time, it doesn't look as if he ripped her off. He may have read her paper and then just written his own stuff and not credited her. That is possible. And we don't know. My personal belief, and it's just what I believe, like we don't know, is that he didn't read it, or if he did read it, he didn't really pay much attention, that he hadn't realized he'd read it, and he may have kind of, it might have planted a seed and he hadn't realized that he was inspired by her work. He wasn't known for paying much attention to women's intellect, or put it that way. He was a bit dismissive of the idea of women being intelligent. So it might be that he saw the name of her name on her paper and just completely skipped over it and didn't read the paper. Or it could have been that he read it but went, pfft. Or he might not have read it, he might not have seen it at all, it might not even crossed his desk. Other people discovered the same thing around the same time as well. It's the sort of thing that if you're playing around with gases on a windowsill, you might discover. So it's plausible that he just came up with it himself. And the other thing is that he did a lot more detailed science on it. He was working in these flash laboratories in the Royal Institution in London. He had a lot more resources. He had a lot more people to talk about with his science. He could develop it a lot more. And what he did was different from what Eunice Foote did. And I think we should credit him in his own right as well. Another thing that's worth knowing about Tyndall is that he did have a lot more privilege because he was a man. He could have a sort of job and status and be listened to and have pictures taken of him in a way that just those doors weren't open for Eunice, despite the fact that she was white and she was quite rich. She still, there were lots of closed doors to her because she was a woman. But Tyndall, he came from a relatively humble background, and he had to fight very, very hard to be listened to in science in the UK, and he'd had to fight quite hard to have a job, to be able to, you know, he wasn't rich like Charles Darwin could do what he wanted to because he'd inherited a lot of money, and he could sit there and think about ants and pigeons and do his science, because lucky old Darwin could just live a lovely life of science. To some extent, Eunice Foote could do that a bit as well. Whereas Tyndall, he really had to work for a living, and he was one of the first scientists in London to be able to be paid to be a scientist, and he had to work very hard to get that job. And he managed to secure that job by being very good at networking, making lots of friends. He was very, very good at finding the right people to be friends with and making friends with them and cultivating relationships. And I think that's one of the reasons why he was remembered. And I think it's really important for us to, when we look at science today as well as in the past, appreciate that a big part of doing science isn't just the discovery, it's making sure that people talk about it and that it's shared, and it's not Eunice Foote's fault that her science wasn't shared. I think it wasn't because she wasn't good at communicating. She wrote a very good paper and she presented it at the AAAS, and in fact it was covered by Scientific American. It was quite mainstream, you know. It was just forgotten, I think, for largely for reasons of sexism. But also he did have these extra, you know, one of the reasons why he was remembered was that he put a lot of work into making sure that his work was communicated, doing popular talks, talking to different people and having networks like that. And I think that's a really important way in which science works in society. And the differences between Foote and Tyndall help us appreciate that. And he also said, in theory, if we had more carbon dioxide in the atmosphere, it would get very hot. But like Foote, he didn't think this was a problem. This was just like a theoretical thing. And people at the time were much more worried that it was going to get cold. They were much more worried about the threat of ice ages, that we might decrease the amount of carbon dioxide in the atmosphere and then it would get colder. And they were thinking of it in part just as an intellectual puzzle. Like, they knew it had been colder in the past. Another scientist had worked out this sort of concept. Several scientists had worked out the concept of ice ages. They knew it had been colder in the past, and they were wondering why was it colder in the past. They thought maybe this carbon dioxide levels thing would explain it. And it was a theoretical thing. It was a maybe this is this. This is just also just interesting play with gases and the nature of heat. It was being a chemist in quite an abstract way. And no one thought at the time that about all of this huge amount of carbon dioxide that was being pumped into the atmosphere because of the Industrial Revolution. Now, this is the 1850s. This is like in the UK, like Tyndall had actually got his career in science through working in the railways. His diaries are full of this really beautiful reflection of working in the north of England and seeing the British countryside ripped up by railways, by coal-powered trains. He had seen that industrialization. In the US, it was starting and it was about to become really, really rapid. You know, Eunice would have been aware of rising kind of carbon dioxide levels because of burning coal, but, you know, she didn't twig it. And similarly, Tyndall, despite living in London, you know, with all of its fog and all of this coal, didn't twig it, didn't think about that. You know, these Victorians were just sort of would generally see technology as kind of a good thing. And I think also there wasn't a belief that humanity would be able to do something as enormous as change the temperature. They thought, you know, that they could see humanity doing really enormous things, you know, ripping up land to build big steam trains, you know, taking steam ships all the way from Bristol to New York. You know, they saw this kind of incredible march of technology at the end of the 19th century. Like, the 1850s is also the first decade that the oil industry started in the US. You know, this is people were doing cracking the earth open to take oil out and then to refine it to kerosene to light up whole new parts of people's lives. They were building things like huge gas networks. It wasn't much longer after that Edison was lighting up networks with electric light. But they you know, could see humanity doing incredible things. But at the same time, the idea that humanity would be able to change the earth, I think, seemed almost unreligious to a lot of people, and just not something that would be possible. So it was all still kept as quite theoretical. So it's kind of just kept on a shelf, these ideas that maybe carbon dioxide might have a role in the temperature of the earth, until some Swedish scientists started looking at this. And the most famous of this Swedish scientists, this is in the 1890s, so a few decades on from Tyndall. The most famous of this, sort of core of this work, was this guy called Svente Arenas. I apologize if my Swedish pronunciation is slightly bad. Now, trivia fans would like to know that he's actually a distant relative of Greta Thunberg, the climate strike, you know, the youth climate activist. It's like her grandmother's cousin or something like that. In fact, her dad is named after him. The family are very proud of the connection. And he was a chemist in Sweden in the late 19th century. He was one of these scientists who was just interested in all sorts of different things. You know, he just was interested in this and that and the other, and had one of those curious minds that just loved investigating things. He also did something that no academic should do, which was that he married one of his students, and then he divorced her quite soon afterwards, and they had a son, and they were going through this difficult divorce, and he was very distressed, and apparently he just found temperature calculations soothing. And he dug up this old thing about carbon dioxide levels in the atmosphere and the temperature of the earth, and it wasn't really the sort of thing that a scientist of his kind of status should really be working on. It wasn't seen as like an important thing to do that a great mind should be studying. It was like a little thing that had been left at the back of the library somewhere. But that was kind of what he wanted. He just wanted something to play with. And he was really into this group of scientists in Stockholm Physics Society, where they'd sit and talk about different scientific ideas. And some of them had been talking about the causes of the ice ages, sort of throwing around this idea and talking about carbon dioxide. And he thought, well, if I did some more maths on this, maybe I'd have something to bring to my friends and we could talk about the causes of ice ages. So he spent months apparently just working these things out with pencil and paper, or the impact of different carbon dioxide levels on temperatures. And he worked out that if you doubled the amount of carbon dioxide in the atmosphere, then you'd get global warming of about 5 or 6 degrees Celsius. No, what he first worked out, because he was really worried about it getting colder, because most people were worried about another ice age, was if you halved the amount of carbon dioxide, it would get 5 or 6 degrees colder. And then one of his colleagues in this physics society said, well, what about like if a load of volcanoes erupted or something, what if it increased the carbon dioxide levels? And he's like, all right, might as well give it a go. I'm just doing the maths, I'm just working it out. And he worked out that if we doubled it, we'd get warming of about 5 to 6 degrees Celsius. Now today, if you go back and do this maths with all the much clever maths equipment and detailed knowledge that we have today, his research wasn't that bad. It was kind of pretty good, considering you're just working it out by hand and had very little theoretical background to put it into compared to what we have now. And then one of his other colleagues sort of went, and this is the key thing, I think, this is the really important realization. And it's kind of baffling that it took till like 1898 or something before anyone did this. It was like, so what about all that carbon dioxide that we're putting into the atmosphere with all this coal that we're burning and all this oil that we're burning? Do you think that could have an impact? Do you think humans burning fossil fuels could increase carbon dioxide levels and maybe make it a bit hotter? This thing that so many of us now think of, we just learn from childhood, that we spend so much of our time worrying about and being concerned about, just was seen as kind of a maybe to these Swedish scientists. And so again, he sort of talked about it and he thought about it. He thought maybe, yeah. And he sort of worked out like how much coal would we need to burn before it would get hot. And he put it in a book that he was writing about all sorts of different things, which was mainly about this theory that seeds had come from space. It was like aliens from space, some kind of like Marvel universe, amazing, cool idea that now looks quite ridiculous. And people, it was an interesting popular science book basically. And in a kind of bit of it, he was like, oh, well, me and my friends in Stockholm have been talking about, ice ages. And we worked out that if we increase carbon dioxide, it would get hotter. And we thought maybe with all us humans burning all this coal, maybe we could get it hotter, but it would take centuries. It'll take absolutely centuries before we get there. And he figured also, one of the things that's really remarkable when you look back at this is it was like, it's probably a good thing. Like, this is true probably of people working on the carbon dioxide climate change issue kind of up until Second World War, is they were like, well, maybe if it would get warmer, maybe that'd be a good thing. Now, that was still 1898 odd, to the turn of the century, by the time his book was published and it had been translated into English. It started to make a few people in the UK and the US were quite interested in it. Particularly a couple of American scientists were really inspired by it for a while and thought that this was a really interesting theory about ice ages, and also kind of interested that maybe humanity might possibly start to build enough technology and emit so much carbon from burning fossil fuels around the world that we might make the world warmer. But then there was some more research that again came out of Sweden and Stockholm that looked at, it kind of repeated a similar research to sort of thing that Eunice Foote had been doing, thinking about how hot carbon dioxide got, but they put it in the context of the whole atmosphere. So they weren't just looking at carbon dioxide on its own in a cylinder, but how the chemistry worked as part of sort of chemical soup of the atmosphere. And it seemed to look like from this lab research, this new lab research, that actually the stuff that Foote and Tyndall had said in the 1850s probably wasn't true, or didn't work in the larger, more complicated environment of the atmosphere, and that maybe carbon dioxide didn't have that much of a warming impact. And so it wasn't long before Arenas' work, which we now look back and go, wow, that is so visionary. In the 1890s, they were warning that if we burnt lots of coal, it would get warmer. It was thrown out. And for the first few decades of the 20th century, it was seen as really fringe science. So some of you might have seen, I'm just going to skip through this. Some of you might have seen this. It's a clipping from a newspaper in, I think, New Zealand. saying coal consumption could affect the climate. And it's if you can find it online, you can probably read it better than this screen grab. But it's basically saying that if we keep burning lots of fossil fuels, it will get warmer. And this is from 1912. And it's one of a few bits of news that came out around that time where people had noticed that it had got a lot hotter. And they were wondering why it had got a lot hotter. And they'd dug up this old work by people like Arrhenius and a few other scientists who talked about his work at the time. And they said, is it because we're burning all this coal? Have we finally got to that point that we have burnt enough fossil fuels that it's getting hotter? And now it goes viral every now and again. So you might well have seen it shared on the internet, because people are like, wow, in 1912, we knew about it. People were warning us. There was this New Zealand newspaper that was saying, if we burn coal, it's going to get hotter. And now look at the problem we've got. Now, at the time, it was actually quite fringe science, and it wasn't really, it was a little bit of a weird idea. We think it came from an article in Popular Mechanics, which you can dig up online. Popular Mechanics magazine has got a really good archive on Google. I highly recommend just getting lost in like 1920s Popular Mechanics magazine. It's wonderful. The adverts are incredible, and all these articles. When I was digging this one out, I looked at the magazine around it, and it had articles like the expression "a canary in a coal mine," where you take a canary down to the coal mine to sort of, if it falls over because it's breathed in noxious gases and it's not got enough oxygen, it's a sign that it's dangerous and you shouldn't let humans behind it. They had an article about the first canaries being used in coal mines. It's incredible, and all sorts of ideas about different technologies. And it's got this very long article by a journalist who'd really dug into this question. He'd noticed that sort of older people would say winters just aren't what they used to, and he was wondering, is this just something that's just something that old people say? Oh, the weather's not like it used to be when I was a kid, or is there something in it? And by the 1912, there were several decades of really good data about the weather held by the Smithsonian. So the Smithsonian had been established several decades before then, and one of the first projects they'd done had been weather research, gathering information that was sent into them on the electric telegraph from all over America. It had this incredible weather map. It didn't tell you a weather forecast. It would tell you what the weather was the day before. And people apparently loved it because it was so interesting to be standing in the middle of DC and know what the weather was like in Florida or Chicago or some other part of America. But it was first kind of one of the first public weather maps. And they had this incredible citizen science project with scientists from all over the country sending in their data. I think Eunice Foote's husband actually was one of the people who sent in the data. And this had been gradually moved to become more professionalized. It was taken on by an area of the US military, and the same is true of countries around the world. In fact, around the middle of the 19th century, lots of countries around the world had agreed that they would not only collect weather data but share it with each other, because it was really useful for developing kind of the early sciences of weather forecasting and being able to warn each other about storms. And also people could make money if they knew better trading routes was the other thing. It was useful for shipping. And so people had quite detailed weather data by 1912. And so this journalist could look at that and go, yeah, actually, it has got hotter. This isn't just an old crazy guy in the bar saying, oh, it used to be cold when I was a kid. It's really is getting hotter. And he dug up this work from a few decades before that said, maybe it's a carbon dioxide thing. And he said, is this that? And it's fascinating to read because he still thinks of it as a good thing. In fact, there's this really quite haunting line in it where he says, maybe in future generations, people will look back and thank us for having burnt so much coal that it will be warmer. And this kind of, I'm going to stop now. If you want to know more about how the story unfolded, you will have to read the book, but we can bring them out in questions if you like as well. But I wanted to leave you with this thought that right up until actually several decades after this, until kind of 1930, which is the point where, or 1940, between 1938 and kind of 1950, the idea that this might be a bit fringe and was slightly silly science started to dissolve. There was new laboratory work that said actually this earlier laboratory work was wrong, so people came back to it. There was new ways of studying these things. There were new computers to help us crunch the numbers, and by kind of the early 1950s, people were going back to this idea that carbon dioxide caused warming, and were by then very clear that it was happening. that it was carbon dioxide was causing some form of warming in the atmosphere, and that it was something they needed to study. And so that is why the Keeling Curve starts in 1958, because by 1958 they were worried enough that they decided to start tracking it. But right up until that point, people either didn't think it was a problem, or even if they did think it was happening, thought it was a good thing. And that is sort of the story of how we did discover the climate crisis kind of in 1856, but we didn't really appreciate it was a problem, I suppose, until 1956, about 100 years later, which is still quite a long time, I think. I want to finish on that note, in that sometimes people come to me and they go, we knew about the climate crisis in 1856. And I was like, we didn't know it was a crisis. We knew about carbon dioxide in 1856, but we did know about the climate crisis in 1956. And that is still quite a long time ago for us to still be procrastinating about taking action on it. And I think I should stop sharing my screen. Is that right?
But you can leave the screen up if you would like, Alice.
Maybe I'll just going to try and find my picture of my book so I can promote it. My publisher would like that.
That's great. Someone actually on chat said that she Googled Eunice Foote and Wikipedia and found a photo of her and her dog, and she's wondering if this picture is fake.
It's not fake. It's sort of, in fact, it was quite, last year it was my birthday, and my colleagues were really excited that they found that picture on the internet, and they superimposed a picture of my face on her face as a card. They were really proud of themselves, and I was like, sorry. It was used, I think it's a picture of somebody else at the time that was used to illustrate a picture of a story about her, which is now used as a picture of her, but it's not unless someone has found one in the last 24 hours that I didn't know about. It's not, we haven't actually got a picture of Eunice Foote quite yet, but it's a common, it's not a fake quite, it's just one that's used a lot because we don't have a picture of her.
All right, there's another comment. Amazing program. What a great job, Alice. Thank you. Patrons, if you have a question, you can put it in chat, or feel free to unmute yourself too. That is an option. I find it interesting, Alice, that in 1962, of course, Silent Spring was published by Rachel Carson, and it was another female that brought the whole environmental movement to people's attention.
And I think one of the things that's really different about her was obviously she was listened to. I mean, she was remarkably listened to. She really kicked off a huge movement. But one of the things I didn't realize until I was researching the book, is people who've studied that era a bit more have pointed out that she was very, very good at working with women, and lots of women's groups read her book and then became the messengers. So it wasn't just her who was raising alarm, but it was all the women who read her book and then talked about it with each other and talked about it with others. And there was particularly quite a lot of women in America who'd become more politically interested because of nuclear issues. And they weren't necessarily kind of activists. They were just, you know, mums and daughters and sisters and workers and just normal women, but they were more politically aware and more up for challenging how we were doing science and technology because of concerns they'd had with nuclear power. And that they weren't necessarily anti-nuclear power, but the kind of discussion about nuclear power had kind of raised people's awareness of needing to have a discussion about pollution and about unintended consequences and the things that you couldn't see. You know, radiation, you couldn't see it, and you couldn't see the kind of pollution that Carson was talking about in Silent Spring, and that these women's groups were one of the really key ways in which that book got out, which I think is really interesting in terms of just different networks. And that's not the sort of network, despite the fact that Eunice Foote was a women's rights activist and was part of lots of women's groups, her science wouldn't have been spread in that way. Not at all, really.
There's several comments. They're looking forward to reading your book. Someone would like to know, what can we do to stave off the crisis?
That's a really good question, and it's one that lots of people have. And because my day job is the charity I work for focuses on practical things that people can do, it's a question that people often ask me, and I'd say that it's going to be different for each and every one of you. And the first thing you should probably do is reflect on just what you can do as an individual, and not beat yourself up about things that other people are doing that you might not be able to do. So some people will be able to stop driving, some people won't. You might not live in a place, you know, that might stop you from being able to see your family, from being able to work, from being able to move around. You know, don't beat yourself up about particular things. I've got a colleague who eats meat, and he's like, I'm a climate activist and I eat meat, but he's got all sorts of other dietary requirements that mean that he would just be ill if he didn't eat meat. You know, this different people have different things, and you do you, and appreciate that you will contribute in a different way. The other thing to think about with your own life is like, what do you currently do that's very polluting? Like, if you never fly, giving up flying isn't going to help. But you know, what do you currently do which has a lot of greenhouse gas emissions that you can cut? So I think that's one of the first things that you can kind of do. The other bit of advice that I give people is do something that will bring you some joy. Like, when we talk about climate change, we often think of it as very miserable, and that it's taking action on climate change is going to make our lives worse. And that's not always true. And also that climate change is very serious, is really awful, makes me very upset a lot of the time. I spend a lot of time worrying quite deeply about it. But taking action on climate change can be an absolute ball. And it's a bit like, this is January, I'm sure lots of us have New Year's resolutions to exercise more. You know, if you're like, right, I'm going to run every day. If you hate running, you're not going to exercise more. If you choose to run, you'll just stop it because you hate it. But if you love swimming, you'll probably keep going. And the same thing kind of works with climate action. So if you love cooking in lots of different ways, it might be that, like, the idea of giving up meat might be something that you wouldn't want to do, but also actually you might have loads of fun being able to be really creative about different types of things that you might cook. And also you will be, not only will you be better at it yourself, you'll also be more infectious. So just think about the ways that you can be inspired by whatever you're doing yourself, but then share that enthusiasm. So like, if you decide you're going to cut down on meat, don't just cook lots of really lovely food for yourself. Invite your friends around for like a big vegan feast and be like, look, isn't this great? If you're deciding that you're going to change how you move around and travel, you know, if you go on holiday and you take the train rather than the plane, take loads of photographs and bore everyone on Facebook about how wonderful Amtrak is. You know, like, make other people inspired by what you're doing. So that's my advice is, think about yourself and what you can do that's going to work for you and your own circumstances. And then do something that brings you joy. If the thing that brings you joy is shouting at politicians, do that. If it's thinking about something to do with transport and the things you consume, do that. And do something that's going to be infectious, because we can't just leave it with ourselves. We have to help other people take action too.
Great. Does your book address tipping points where temperatures might accelerate above the current forecast?
So my book is very much about the past. It finishes in kind of 2009, 2010. So it doesn't look forward to tipping points. I have actually written another book. Conveniently, I have it. Which is called Can We Save the Planet, which is also published in the US and also in several other languages. If you want to read it in Italian or Spanish, you can get it that too. And it's like a guide to environmental environmental problems, so climate, but also plastics and biodiversity loss. I did it with an arts publisher, so it's got loads of pictures. It was a really interesting project to work on because they had all these amazing pictures, and they were like, how can you help explain science with these pictures? So it was really interesting as a science writer to be able to work on this project. And yeah, they gave me the title as well. They were like, Can We Save the Planet? And I was like, I don't think that's a good title, because I don't know who the we is or saving or why we would, like, it's not how I would think about the topic myself. But actually it was a really interesting introduction to thinking about it, and I was challenged to be like, can we save it? And one of the things I had to look at was this issue of tipping points. And I had a very depressing couple of days reading about things like, if we destroy enough of the rainforest, it gets to the point that it will then emit a huge amount more carbon, which will then, you know, melt enough of the Arctic that would emit even more greenhouse gases in the permafrost, and we just sort of go beyond a point. But I would stress that we're not there yet. When people talk about the danger of getting beyond 2 degrees Celsius global warming, so often in discussions of climate policy, people talk about 1.5 versus 2. These numbers, like I said at the beginning, people give you these numbers. These are 2 big numbers that people talk about. And certainly a lot of the climate debate at the moment is whether we can stay under 2 degrees. And one of the reasons why that is so important is that over 2 degrees, the risk of those tipping points become a lot higher. And that's one of the reasons why the next 5 to 10 years is so incredibly important for climate action, because if those are our opportunity to keep global warming to under 2 degrees, And that will still be horrific for lots of people around the world. Climate change is already horrific for lots of people around the world. We're about a bit over we're about 1.2 degrees Celsius, if you want to kind of think about where we are, kind of how close we are to that at the moment. But it still would mean that we'd hope that we'd be able to avoid too much risk of those tipping points.
Someone is asking, what is your next project or next book?
I'm not sure if I'm going to write another book. For a long time, because I was a journalist before I was a climate campaigner, and I was an academic before then. So people would say, are you going to write a book? And I thought about it and I thought, no, because I want to take action on climate change. And I'm not sure that books, like, Silent Spring is a book that changed the world. I'm not sure that a book about climate change will change the world. I think we need to tackle climate change in different ways. I don't think just giving people more knowledge about climate change is what we need. I wrote this book because I do think that history is under reflected on in climate change, and I thought it would give something, it would give a lot to people who are interested in the issue. And I also just thought it would be a fun book that people would enjoy reading with lots of interesting characters. But unless I can find something where I feel it would be useful, like the thing that gets me up in the morning is taking action on climate change, and I'm not sure if another book will do that. If I can come up with an idea for a book that I think will be helpful, I'll do it. Like, I was interested to do that project with an arts publisher because it allowed me to talk about climate change in a different way with different people. But at the moment, I don't have plans for that. I'm working with the charity that I run in the UK, which works primarily just in the UK, although we do have a project in New York as well, and one in Paris. And we do some work on, one of the big things we're doing at the moment is work to develop solar powered trains. And the technology we're testing in the south of England at the moment would be usable all over the world. And we'd really hope that we could use it in urban metro systems like trams and trolley buses and things, as well as underground railways, things like the metro in various different cities, as well as intercity rails. So maybe in a decade's time, you'll be able to take a solar powered Amtrak somewhere, and I might have had something to do with that happening. That's kind of one of the things I'm really working on at the moment.
Oh, that would be awesome. There's other comments. Let me see here. Very interesting program. Thank you. You're a treasure. Sage advice. Can't wait to read your book. I think many people are going to be interested now in reading your book. This is interesting. Thank you so much for the epic presentation. Keep on fighting the good fight. Someone says here, have you seen the Netflix 3 series Inside Bill Gates's Brain? If not, I highly recommend it. He had an R&D company called TerraPower project to determine if it's possible to build a new safe nuclear power plant.
That sounds really interesting. I think nuclear is something we're going to talk more and more about. It's one of the things I didn't mention too much about in the book because there is already quite a lot written about the history of nuclear. But it is a really interesting topic. Not least because of the way it interacted actually with the history of climate change research. So the bit of the story that's sort of after the bit I told today, where we go into the 60s and 70s and 80s, we see, first of all, I think we see a lot of the environmental movement against nuclear. And one of the things that did was they didn't look at issues like climate change because they were fighting nuclear. Now they did a lot of work with that. But it's one of many other things. They were basically fighting a lot of battles, which meant that they didn't fight the battle of climate change for many years, I think. One of them was that. But the other thing is that it helped, and people talking about nuclear also helped a lot of climate change work. And I think that particularly in the 70s, some of the strongest advocates for action on climate change and for more research on climate change were people who were also nuclear advocates. And it's really interesting to see that, because it's very easy to come to the nuclear debate as either being, I like nuclear, I hate nuclear. And I personally am kind of in between. I think it's a bit more complicated than that. And it's really interesting to see that complexity played out in the story of how we discovered and started to take action on climate change, both for good and bad. It's not a simple story, but it definitely colored the debate about climate change for a long time, I think.
All right. If anybody has any other questions, please put it in chat. I do want to remind you that our next Nature Speaks is on Thursday, April 21st with David Schwagler, and he'll be talking about the Lake in the Hills Fen. So if you have any questions, please put them in chat, or you can unmute yourself. Thank you so much for spending, well, it's your evening with us, Alice. And I know that our library has your book and it's available on Amazon, correct?
Yep.
And lots of other places.
Bookshop.org, all the usual places. And there's an audio version as well. It's really lovely reading, I think. I'm very pleased I didn't need to read it myself because I would have been exhausted. They got a very good reader to read it. Really brings it to life.
All right, lots of thank you. Awesome program. Thank you so much, Alice. We appreciate you spending the time with us and enlightening us. And everybody come back in April and we're going to take a tour of one of Illinois' best kept secrets, the Lake in the Hills Fen, which is a natural, wonderful natural place that you can go and hike. So thank you again, Alice, and good luck in your endeavors with your charity.
Thank you.